Okay, let me talk about arc length. So using this function, let me pose a question. What is the arc length of the curve from t equal to 0 to t equals to 9? Okay, so you're given a curve. I don't even know how it looks like, but I have to figure out the arc length from here to there. Now, what's easy to find is the displacement. What's the displacement? It's simply terminal minus initial, right? Displacement is a vector. So if you plug in 9, and what does that give you? That's 18, let's see, 3, 20, 36, 81 over 2. That's your terminal position. Minus, when you plug in 0, 0, 0, 0, so you get the origin. So it went from the origin 0, 0, 0 to 18, 36, 81 over 2 when t is equal to 9. So you can figure out where it was, where it ended, and the vector from the first position to the second position is what we call the displacement. Right? Now, however, the magnitude of displacement is not the arc length, because most likely this is something curved, right? So would it be bigger or smaller than this magnitude? What do you think?
Bigger.
It would be bigger, right? The arc length should be bigger. But how do you get it? That's the question. So let's just write down that remark I just had. So note, at t equals to 9, RT is equal to 18, 36, 81 over 2, if you computed it, and R of 9. And therefore, also at t equal to 0, R of 0 is the origin. So the displacement is the difference of the two vectors. It's terminal minus initial, right? Terminal point minus initial point, which is 18, 36, 81 over 2. Okay? And if you were to calculate the norm of this, it will be a value that's actually smaller than the actual arc length, because this is a curve. It's not a straight line. This will be the straight distance from the time t equal to 0 to t equal to 9. If you take the norm of this, that's going to give you the straight distance from here to there. All right, so how do you actually find the arc length? Well, here's the reasoning. I have no idea what that curve looks like. Let's just say it's some kind of curve that looks like this. And here's t equal to 0 and t equals to 9. I want this length. What I do is first I take the derivative, which is 2 square root of t and t. If you differentiate this, you get this. And that has the meaning of velocity, right? This is the velocity. Now, if you take the norm of the derivative, what do you get? So that's the value of the norm of the derivative. But what's the physical meaning of this?
Your tangent?
Huh?
Tangent?
No.
It's your unit.
The direction is the tangent. So if you have a velocity, the direction gives you the tangent vector, but the magnitude of the velocity is
Your size.
Speed.
speed. Speed, right? Magnitude of velocity is the speed. And think of it this way. This measures how fast it's moving, right? 2 plus t. Tells you how fast it's moving. And therefore, if you multiply it by dt, this is going to tell you how fast, how much distance it covered in a given time dt. And if you want to know the total distance traveled, what do? You integrate it from t equal to 0 to t equal to 9. So it's like this. This speed is change of distance over time. That's what it is, right? Speed is change of distance over time. Therefore, if you have ds, change of the arc length, that's same as the norm of the velocity, which we call the speed, times dt. And therefore, if you wanted to recover your distance traveled, you add up all these small distances, right? And that's why we have to add up these things. So that's the formula that we have to use. So let's finish up this calculation, and I'll give you the formula for it. Okay. So the calculation is that this is 2t plus 1/2 t squared. And when you plug in 9 and 0, this is 81 over 2 plus 18, which is 36,117 over 2. That's what you get. So that's the arc length from t equal to 0 to t equal to 9. And the main argument here is the following fact. Arc length is usually denoted by s, lowercase s. Capital S is for surface, lowercase s is for arc length. Capital S for surface area, lowercase s for arc length. And this is the integral of the norm of dr dt. dt. That's the formula. If you want to know from t equal to a to t equal to b, this is the formula you use. Any questions? It's a very easy formula to use if you think about it. What do you have to do? Differentiate, take the norm, and integrate by t. That's all you do. If you do it, then you get the arc. That's how you do it.